Hey guys, welcome to my channel. In this video, I'm going to be showing you how to make a custom battery for your AIBO ERS-210 or 220. This tutorial only covers how to make a custom battery for an ERS-210 or 220. For a 7, the process is a little more complicated, and I may make a video on that in the future, but for now this is how you do one for a 210 or 220. You will need to know how to solder for this process. You will need to buy the stuff that's in the spreadsheet in the description. So yeah, let's get started. To begin, you're gonna wanna pry your battery open. I used a kitchen knife, but it's held together with adhesive. Just be kind of gentle with it until it starts prying open, and then you can pop it open. Then the cells might be stuck in place. You just have to be really gentle, but wiggle them out. As you can see, mine are pretty cooked. And then, so how to desolder, you start with the black, then you do the gray, and then you do the one that's soldered directly to the cell. Make sure the temperature sensor is untaped, because you're going to need that later. Once that battery board is all desoldered, we're going to want to flash the EEPROM, and that is going to be done by clipping our EEPROM flasher clip to this chip right here. Okay, so once you have your chip connected, make sure it's connected like this. I don't know if you can see how I have it lined up, but those wires go there, and those wires go there. It's pretty much lined up the exact same way as the chip. So once that's all wired up, it's time to flash your EEPROM. When you flash the EEPROM, when you first connect it and you get your data, there's an option to save in the software, and I would highly recommend doing that in case you screw up any of the values. You can restore your backup of the original data. Alright, so if this is hooked up to your computer, you're going to want to run the programmer software, click 24 EEPROM and hit read. And it should fill up with some values. So the main values we want to worry about is design capacity, full charge capacity, and cycle count. And I already have them changed here, but your design capacity is these 4 numbers right here, and your full charge capacity is these 4 right here, and your cycle count is this here. You're going to want to set your cycle count to 1. And then for me, because my batteries are 2400 milliamp hours, you're going to want to change this to 6009. And then the same thing for the full charge capacity, 6009. Then you want to erase the EEPROM and hit write. And there you go. You have flashed your EEPROM. It's important to note, to get this value for 2400 or whatever, you need to use a hexadecimal to decimal converter. And essentially, this is 2400 right here, but you have to put the hexes, like the lowest value before the highest, I guess. So that's why it's laid out a little bit different in here, where it's 6009 instead of 0960. But this should be correct. So once you've done that, you have successfully flashed your EEPROM. Alright, so once you've flashed your EEPROM, if you needed to, you're going to want to make your battery. So this is actually a custom 3D printed battery enclosure. If you want this, you can ask Abby on RoboChat, and he'll send this to you, I think. I printed this in PETG, 25% infill. Worked fine on my printer. But anyway, this is what it looks like fully assembled. I opted to go with nickel-plated springs instead of the regular AAA style springs that you can get on Amazon. So first, how this is wired up is your positive, plain and simple, soldered directly to where the battery was, is right here. That's your positive, right? Then, for the negative, it's this wire here, and it wraps all the way around and touches there. And then this red wire connects these 2 terminals so that the cells go into series. So, and then this white wire is connected to this one, which gives off the 3.7 volt. That's where the gray wire hooks up to, is this right here. So yeah, that's essentially how it's hooked up. I'll probably include a diagram or something just so you guys know what any of that means. And then the temp sensor has been relocated to like right here. So once that's done, yeah, we're ready to install our cells. All right, once your cells are installed, these are the ones I chose. Make sure you read the polarity correctly. Little tip about installing these: make sure that the last cell you install is this one, and make sure that the last contact is this positive. I've just heard that if you don't do it that way, it could blow the fuse. So yeah, once this is done, you should be able to stick it in your dog and it should charge and work just fine. I would suggest, once testing it, that you cover the inside with hot glue so nothing moves around and then put the cover on. So yeah. One more thing I'd like to mention, once you have it all wired up, go ahead and test your polarity here. And you should get about 7.5 volts if it's all wired up correctly. Once this is done, you can douse in hot glue and seal it up and it should work. Now, if everything's been done correctly, stick this in your station. And it should start charging. There you go. So once your battery is all charged up, stick it in your robot, and it might be kind of a tight fit, but it should fit. And turn it on. And if all worked correctly, your ERS-210 should boot. There we go. As you can see, he's booting just fine. So yeah, this has been a successful Recell. Thanks for watching.